Hello there guys, and welcome back to another Epic Inexorable Maths video. In this video we're taking a look at radians. What are they? Why would we use them? So a quick definition of what a radian is a radian is an alternate way to measure angles. So just a really quick thing is that in a full circle you have 360 degrees. That is equal to 2 pi radians, and we will look at why that is right now. So that's just a fact, right? So there's 2 pi radians in a full circle. But what is a radian? Where does this thing come from? Why would we use them? This is it. Imagine a circle. Okay, it's not a very good circle. I acknowledge that. That one's not much better, but we'll just go with it, okay? Imagine that this is a circle. Perfect circle. If we take the center of that circle and we arbitrarily just choose any point we want, a straight line going from the center to a point on the circumference of the circle. Now, let me ask you a question. What is that? Well, we can say that's one radius of the circle, can't we? That's going to be r. Okay. Now, this is what a radian is. If we then, whatever the radius is, if we go round the circumference of the circle by the same length as the radius, so that this length here, that I will actually do in a different color, in purple, this length here is also r. It's the same length as the radius. So an arc length that is the same length of the radius of the circle. And then we connect another radius from the same center to where that point stops there. Oh, what's happened there? But yeah, we make a line that looks roughly like that. Going not very straight lines. But if we were to do this, and then we were to say, what's that angle there? Theta. What is theta? Theta is 1 radian. Okay, that is the definition of a radian. A radian is the angle made by between the center of a circle and an arc length, the beginning and end of that arc length, that is exactly 1 radius long. Okay, we define that as 1 radian. That's the definition of what a radian is. As a consequence, we might want to know, well, how many of these thetas, how many of these angles, radians, are in the whole circle? Well, we know that the circumference of a circle is 2 pi r. That's a formula for the circumference of a circle. So what we can say is if we can find out how many radians are in the circumference, then we can be happy that that's going to be our 360 degrees, and then we have a conversion factor. We can convert between radians and degrees if we can figure out how many radians are in 360 degrees. And of course we already know that. I wrote it already. It's 2 pi radians. But this is why. 1 radian corresponds to 1 radius going round the circle. So this in the circumference of a circle, you've got 2 pi radii, which means if you were to go round with another r, there's another r for you, there's another r, etc. Keep going round. You would end up with 2 pi r's, wouldn't you, in the circumference? There would be 2 pi r's. And each angle theta corresponds to 1 r, doesn't it? Which means as a consequence, you have 2 pi radians in 360 degrees. That's why it happens. Because you need 2 pi radii to go round, and each radian corresponds to 1 radii, or 1 radius. So in 2 pi radians, that is 360 degrees. Which means if we want to convert between radians and degrees, we have a simple conversion factor. We can simply say that 1 radian, 2 pi radians is 360 degrees. So dividing both by, because we can say they're equal to each other, dividing both by 2 pi, 1 radian is 360 divided by 2 pi degrees. And that fraction is actually going to simplify to 180 divided by pi degrees. Okay, so to convert from radians into degrees, you multiply by 180 over pi. to convert, which then means to convert from, so I'll write this, radians 2 degrees you times by 180 over pi, okay, and to go backwards, degrees to radians, that means that what you have to do is simply times by the reciprocal, which is times by pi over 180, okay? Now, 180 over pi, I believe it's something like 57, so I'm just going to check that now. Yeah, so roughly, if you want it as a decimal, you can say basically that 1 radian is roughly 57.3 degrees. So a radian is a much larger angle than a degree is. It's about 57.3 times as big. Okay. Now, the reason why we use these is because when we do things like calculus, you must be in radians for it to work. Calculus only works in radians. It does not work in degrees. So differentiation and integration only works in radians. There's lots and lots and lots of reasons why you would use radians, but this is one of them. Radians are a more natural unit of measurement of angles rather than degrees. The reason for this is simply because degrees are totally arbitrary. We invented this number 360. We defined 360 out of nowhere. The only reason we use 360 degrees in a circle is because 360 is divisible by lots of numbers, so it's quite an easy one to work with. But there's no reason why we couldn't have said, hey, there's 400 degrees in a circle, or there's 500, or there's 100 degrees in a circle. There's no reason why we couldn't have done that. We could have done. We just chose 360. But radians are a natural unit of measurement. They arise using the definition of the radius of a circle and the circumference of a circle. They're much more natural. They correspond more to geometry. If you enjoyed this video, like, subscribe, share with your friends and family. Hope that this was helpful, and I'll see you in the next video. Cheers.